Alright, so hi everybody. This is going to be our first unit, lesson 2. So we are going to be covering what is known as the distance formula. And there's been a time or two in the past when y'all should have seen something similar to this. The Pythagorean theorem is kind of a simplified version of this. But the distance formula isn't too bad as long as you can remember how it's set up. So, the I-can statements for this lesson are: I can use the distance formula to find the length of a segment. So, the distance is an amount of space between 2 points or things or people. So it's just how far apart things are. And so when we are dealing with, geometry, sometimes we want to figure out how long something is or how far apart the 2 points are. Like, for example, if I have this square, or rectangle rather, and I want to figure out how long this side right here is, well, I want to find the distance between this point and this point. Sometimes it's as simple as counting. Sometimes it could be even more simple, and there's just a number here. But sometimes we have to figure it out a different way. And that's when the distance formula comes into play. So this equation here, if it looks complicated, it's not as complicated as it may seem. All it says is the distance formula, distance is equal to the square root, which is this little symbol here, of one x-coordinate minus the other x-coordinate squared plus one y-coordinate minus the other y-coordinate squared. So to use distance formula, we need 2 points. And this again is the formula used to find the distance between 2 points. So before we hop into just practicing the actual distance formula, let's break it down piece by piece. So the first thing we need to do is differentiate between x and y. So coordinates are almost always alphabetical order. So in the alphabet, x comes before y. So x is the first coordinate and y is the second. So remember, alphabetical order, x comes first, then y. It's important to not get mixed up. So now let's look at this with some real numbers. So we have a 2 and we have a 3. Which one's our x-coordinate? Well, it's 2 because x goes first. And then the second coordinate is y, so we can split those up. So it's pretty easy to distinguish between x and y as long as you know your alphabet. Okay, so now let's say we have 2 points, because the distance formula deals with 2 points. I have xy here and xy here. So one thing that people tend to do with the distance formula is they want to pair up these coordinates together, the x and the y. But for the distance formula to work, we have to pair up the x coordinates and the y coordinates. So the x coordinates are the first one of each coordinate. So we can call this x1, we can call this x2, or we can call this x2 and this x1. Truthfully, it doesn't matter, but let's just do them in order. x1, x2. So we're going to take our x's, and we're going to pull them out, and we're going to put them in this, like we're going to subtract them. Then we're going to do the same for y's. We have y1 and y2. So I'll go ahead and put these little symbols here too. I'm going to pull this y out, and it goes in here, and then this goes in here. So again, what I'm doing here is I'm taking the x coordinate from both of these coordinates, and I'm putting them together in parentheses, and I'm subtracting them. So this is x1 minus x2. And over here I have y1 minus y2. Okay. So here is what happens if we do it with actual numbers. I'm going to take the x1 and x2, and I'm going to put them in here together. Okay. x1, x2. Now, again, you can flip these around because this doesn't matter too much later on, but we'll just do an order for now. So then we have 2 minus 4. Well, what's 2 minus 4? Negative 2. Let's do the same thing for y. We pull out our 3, which is our y1. And we have our 6, which is y2. Put them together in parentheses, subtract them. We have 3 minus 6 is negative 3. So for the x's, we found that the distance between the x's is negative 2. And the difference between the x's is negative 2. And the difference between the y's is negative 3. Okay. So let's take this another step farther. Again, each of these steps is us getting closer and closer to the distance formula, just building up, showing what to do. We start off with being able to distinguish between x and y. We figure out how to set them up in parentheses, like this. Then we're going to learn how to square them once we're done. So we split up our x and y's, and everything's just like before. The only difference is, once we split it up, we have this set of parentheses. So we have an exponent right here. So we said that 2 minus 4 is negative 2. We want to make sure we keep that in the parentheses, and it's going to be squared. Now over here, we said that this was negative 3. So we're going to take this negative 3, get in parentheses, and square it. So negative 2 squared is the same thing as negative 2 times negative 2, because I'm multiplying negative 2 by itself twice. And a negative times a negative is positive, so this is going to give me 4. Same thing over here, negative 3 squared is just going to give me positive 9. Never negative 9, just positive. So we found this is 4 and this is 2. So now we have the next step. Once we're fine with squaring these, we need to combine them through addition. So again, these are the same numbers as before. And we found that 2 minus 4 squared is 4. So I can say that this is 4 plus, and I said that 3 minus 6 squared is negative 3 squared, which is 9. So I can say that's 4 plus 9. Well, what's 4 plus 9? 13. Now, admittedly, this example doesn't work out as neatly as I had thought it was going to originally, but that's okay. So we found that all of this right here can be simplified into 13. I split up my x's and y's. X's go to this one, y's go to this one. Subtract them, square them, add them together. So next is the last and final step. We need to throw it under a radical. So this might be a little confusing. We're just trying to find the square root. So 2 minus 4 is negative 2. Negative 2 squared is 4. Plus 3 minus 6 is negative 3, which squared is 9. So I have 4 plus 9, which we said was 13. Again, I'm just building up with the same numbers each time. So I can say this is equal to the square root of 13, which this doesn't simplify, so this ends up being our answer. Square root of 13. Now, if you have a calculator, that's going to be 3 point something, but I can't think of what that is off the top of my head. All right, so now let's take a look at an example. Just start from scratch. So let's give ourselves two coordinates. So here are our coordinates. We have 6, 3, and 2, 6. First thing I need to do is, let's just go ahead and write out the entire distance formula. So we have d is equal to the square root of x1 minus x2, which again, this could also be x2 minus x1. It doesn't matter too much on the order, squared, plus y1 minus y2 squared. So let's fill this out. So I have the square root, and then I need to pull out my x's. So x1 is going to be right here. So I have 6. We have subtraction here. So where is my x-coordinate coming? Second x-coordinate coming from? Remember, there's only one x-coordinate per point. So I've already used the x-coordinate here, so I can't use the 3. That has to be a y. So we have to use this 2 over here, which is going to be x2. Let's do the same thing with our y's. y1 is here. So that's 3. And y2 is here, which is 6. So we split it up, we've set it up. Let's get it going. So first thing we do inside of the parentheses, 6 minus 2 is 4. Inside parentheses here, 3 minus 6 is negative 3. All right, let's take on to the next step. 4 squared is 16. And negative 3 squared is 9. All right, we're getting there. Add these two together. 16 plus 9 is 25. And the square root of 25 just so happens to be 5. So we can say that the distance between 0.63 and 0.26 is 5 units. And that's the basics of how the distance formula works. You take those points, you plug it into the distance formula, and boom, you're done. All right, so if y'all have any questions, just let me know, and have a good one.